As I mentioned a few slides ago, we use the technique of dimensional analysis a great deal in chemistry to solve a wide variety of problems, not simply unit conversions. So even though unit conversions is our way of first getting into the topic, we will continue to use this technique for many of the chapters from here on out, and in many further chemistry classes for addressing different problems. So essentially the way we do dimensional analysis is like this. You look at any equation, like for example where we say 1 foot equals 12 inches would be an equation, or any equivalence relationships where we say that two things, while not being exactly the same, meaning usually they don't have the same unit, they do have a certain relationship. So for example, speed, 65 miles per hour. 65 miles and 1 hour are equivalent. But an hour is a time unit, 65 miles is a distance or length unit, so we would say they are equivalent in the context of 65 miles per hour, but not equal. In either case, we don't really need to worry about that distinction, but what we do need to know is how to use an equivalence relationship here. So writing either an equation here or an equivalence, we say 1 inch is equal to 2.54 centimeters exactly, and we can change that into one of two conversion factors. So we can put one quantity in the numerator and the other quantity in the denominator, or we can simply take the inverse of it. We will usually use the first of these, the one on the left, to go ahead and convert centimeters to inches, and on the right we would use that typically to convert inches to centimeters. So we would do the opposite there. Now, we can also use, as I said, the technique when things are equivalent. So I used a second ago speed as a possibility, miles per hour. We could also use this, for example, in cost per unit item. So we could say that 1 gallon of paint costs $12.95. Now, a gallon of paint is not the same thing as $12.95. However, expending $12.95 is equivalent to getting 1 gallon of paint. That's all we're saying now. So we can use that in exactly the same technique. 1 gallon of paint for $12.95 or $12.95 spent for 1 gallon of paint. So we're going to go ahead here and use dimensional analysis to convert 128.3 centimeters, first of all to feet, which is a non-SI unit, and then to nanometers. So what we're going to do here is we will just simply start with the relationships we need. We know we can go from feet to inches by the fact that 12 inches is equal to 1 foot. And I can use the relationship from just a little bit earlier in the notes here that 1 inch is equal to 2.54 centimeters in order to do that last step. So what I'm going to go ahead and do here is I'm going to do this as what is commonly called a train track, which is I will simply draw a straight line. And I'm going to go ahead here and write in my starting value, my given value of 128.3 centimeters. So that's my starting value. I'll draw a line here to indicate that I'm going to multiply by a conversion factor. Now it's very important that the unit I want to get rid of be diagonal or on the opposite side of the unit I have here. So we saw that there are 2.54 centimeters in 1 inch. So centimeters cancels. And we know that there are 12 inches in 1 foot. Okay, solving for this gives a calculator answer of 4.2093. So 4.2093 is the calculator answer. And going back here, I'll just cancel those inches. 128.3 has 4 significant digits. 2.54 centimeters is exactly 1 inch. That's unusual in that for an exact relationship, we do have a decimal here. In most cases, exact relationships are integer numbers, but this is the one exception that we'll see a lot. So since it's an exact relationship, we don't look at significant digits for those. And 1 foot is exactly 12 inches, so we don't have any significant digits to worry about there either. So we need 4 significant digits here. So I'm going to round this to 4 significant digits, which would be 4.209. And the unit that's left over is feet. Okay. Now let's do the same thing for the next problem. So I'm starting off again with 128.3 centimeters. Now from here, we want to go from one metric unit to another. So there's a couple ways we could do this. Probably the safest way is to go by the base unit meters. So we're going to convert centimeters to meters. And the way I usually do that is I write 1 in front of the unit with the prefix, and then what the prefix means in the numerator. So centi is 10 to the minus 2. And then I need to, so that cancels centimeters. I need meters in the denominator to get rid of it and put nanometers up in the numerator. So I put a 1 in front of the unit with the prefix, the nanometer. And I put what nano means on the opposite side, which is 10 to the minus 9. And meters cancels here. So after simplifying, this would be 128.3 times 10 to the minus 2 over 10 to the minus 9, a division. So we subtract. Negative 2 minus negative 9 is the same thing as negative 2 plus 9, which would be 7. So 10 to the 7 nanometers, which is the correct value, but it's not in proper scientific notation. So let's go ahead and get it to that. It would be 1.283 times 10 to the 9th nanometers. Now, we also could have just done that in one step, if you'll recall. And to do it that way, we could just say here 128.3 centimeters. If we wanted to go directly from centimeters to nanometers, we put the reciprocal of what each prefix means in front of it. So the reciprocal of 10 to the minus 2 is 10 to the positive 2. And then up here, the reciprocal of 10 to the negative 9 is 10 to the positive 9, which would again give us 128.3 times 10 to the 7, which of course is equal to the answer we got previously. Let's just go ahead and go on to the next problem. And this one is a little bit different in that it's not just unit conversions, but it's going to involve some of these equivalence relationships. So we're saying that 1 foot of 26 gauge platinum wire costs $85. How much would 55 decimeters of the platinum wire cost, assuming the cost to length ratio is the same at any length? And we're going to say just round to the nearest dollar instead of worrying about sig digs. One thing I would like to note when I'm doing these problems, the fact that it's 26 gauge is irrelevant. Numbers can sometimes confuse students, so I'm just going to cross that out and say it's platinum wire. So we say that 1 foot of platinum wire costs $85. So as an equivalence relationship here, I can say that's 1.00 feet is equivalent, which means I'm just going to use 3 lines, or I could just use a colon if I wanted to, and just to say that this is the ratio. The ratio is 1 foot is going to be $85. Either notation would be fine. And what we want to know here is what's the cost of 55 decimeters. So the goal is going to be to get from, since we're given a length, we want to get from decimeters to feet. And once we get to feet, we can use this relationship here to get to the cost. So I'm going to start off with my 55 decimeters. I want to get that to feet. So what I need to do here is, let's just go to centimeters, because we know the relationship of centimeters to inches. Normally, as I said before, I would recommend going from decimeters to meters and then meters to centimeters. But let's use the technique I just used here. So we're going to put the opposite of what each prefix means here. So deci is 10 to the minus 1, so let's use its reciprocal. That's 10 to the positive 1. Centi is 10 to the minus 2, so we put 10 to the positive 2 up there. And again, if you go back and look at the last video, you see why that works. So that gets rid of my decimeters. We now want to get to inches, since we know inches to feet. So centimeters in the denominator and inches in the numerator. 2.54 centimeters is 1 inch. And there are 12 inches in 1 foot. And there is no reason to stop right there. Let's keep track of our units. Centimeters cancel, inches cancel. We're going to use our equivalence relationship here that 1 foot is equivalent to $85. And this one is not one that I can do in my head. However, if we'd like, what we could do is we could simplify 2 to the second over 2 to the 1. Excuse me, 10 to the second over 10 to the 1. 2 minus 1 is, of course, 1, which is just 10. So let's go ahead and put that in the calculator here. So we have 55 times 10 divided by 2.54 divided by 12. You notice I'm multiplying everything that appears in the numerator, divide by anything that appears in the denominator. So then finally times $85. And no reason to say divide by 1, because we know that something divided by 1 won't change it. And so I get 1,533.79. And the problem here says that we are going to round to the dollar, nearest dollar, so $1,534. And I will continue in the next video to look at this same subject, but going into areas and volumes.